So we've been able to find the derivative at a point. And we know the derivative means the slope of the tangent line, the rate of change, or the instantaneous velocity. Now so far, we have found the derivative by doing the limit as x approaches c of f of x minus f of c all over x minus c. And this gives us the derivative of the function f at c, at one particular place. Now, one thing that you should notice about this is if we drew a graph of what's happening here. So here is maybe the c that we're trying to find the derivative of, and this is our f of x. Now, if I were to draw in a tangent line, what we're really doing is we are picking an x that's getting very close to c, and it can be getting very close to c from either side. So this gap between the c and the x that we pick is actually very, very small. So if we were to select a point close to x, well, or c, I guess in this case, we could actually rewrite this formula in a little bit of a different way. So we're going to go ahead and look at that. So let's say that we'd like to find the derivative at a point, or we'd like to find the derivative, I guess you could say, in general. So let me redraw a graph here quick. So here's our function still. Here's our tangent line. It's going to touch at this point. We'll make the point really big. And we're going to call this x. Okay. So what we're going to do is we're going to pick a number very, very close to x on either side, basically. Kind of think of it that way. Okay. So let's mainly talk about the right side. Okay. We're going to call this gap here, very, very small gap in between, we're going to call that h. So that means that the x-coordinate of the point h away from x is x plus h. So therefore, we actually have a new limit definition of the derivative. And so, here's what we could do. What if we took the limit as x approaches, or let me back up here, as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. This formula that I just wrote is very much the same as the last one we've been using. It's just a different way to look at things. And what it allows us to do, see, this first formula really focuses on finding the derivative at c and only c. The second formula helps us to find the derivative at whatever x we're looking for, as long as the gap is closing. Now, you'll notice that down in this part, that could be simplified, couldn't it? So I'm going to go ahead and do that. In fact, the denominator just becomes an h. So what we have then is we have the limit definition of the derivative. And so what this allows us to do is it allows us to find f prime of x, not just at a certain point, but at any point, and with what we call in general. We're also going to refer to this as the difference quotient. So what does the difference quotient look like? Well, we can now say that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And yes, you need to know that. Now, sometimes in other texts, that h might be referred to as a delta x. But they're both approaching 0. That gap between the x we want to find the derivative of and the point that we choose is just increasingly small. Okay. So what I want to do is I want to show you how this is set up in this video here. And then we kind of want to work backwards off of it just a little bit as well. Okay? All right. So we're going to write a formula in my first example here. Let's say that f of x is equal to x cubed minus 4x plus 7. And we want to find f prime of 1. So the way we would set this up is we would say f prime of 1 then is equal to the limit as h approaches 0. All right, so our 1 is our x in our formula up here. So we're going to have f of 1 plus h minus f of 1 all over h. So what that's going to look like when we plug things in is every time I see an x, I'm going to put a 1 plus h. So for this part right here, here we go. This would be 1 plus h all cubed minus 4 times 1 plus h plus 7. I'm done with that part. Now I need to subtract the value of the function at 1. So that'd be 1 minus 4, which is negative 3. Negative 3 plus 7 is 4. And then I need to put that all over h. And I've done it. So the question is, based on that, take a look at that for a second. What if you were given the formula? Could you find the function and the x value? And so let's look at that little aspect of things. All right, so this time, in our second example, let's say we have the limit as h approaches 0 of the following. 7 times negative 2 plus h squared plus 3 times negative 2 plus h, forgive me for the yellow line, minus 22 all over h. And we're asked to find the function and the x value. So what we're looking for is, first of all, the x value. Well, the formula says x plus h, so I have a negative 2 plus h every time, so that's negative 2. Now, every time that I put in a negative 2 plus h, that would stand for an x. So our function, 7x squared plus 3x, is what it appears to be. Now, how do I know I'm right? Now, again, this part right here is an x because I've substituted x plus h. This part here is an x because I've substituted an x plus h, or negative 2 plus h in this case. If I can put negative 2 into the function that I wrote over here on the left and get 22, because remember it's minus, I think we've done it. So it'll be 7 times negative 2 squared plus 3 times negative 2. So that's 28 minus 6, which is 22. And we've got it. We've got it. We are correct. So let's take a look in your study guide for just a moment. And I want you to go ahead and do part A, but I only would like you to do A and B. And look at what we just did. And in the next video, we'll look at part C. So pause the video and take a look at this. All right, I would do part B first. The 4 is the value of x. Now it appears that the function is going to be x squared minus 2x plus 3. And we can verify that by putting 4 into that function, which would give us 4 squared minus 2 times 4 plus 3. So 16 minus 8 plus 3 is 11. And it should be right there. All right, we're on our way to finding the derivative not just at one point, but at multiple points as we move on in this concept. We'll see you next time.